Hello, everybody. So let's get into lesson 4. Thank you again for tuning in. Thank you for tuning in. And so we're still doing vectors and scalars. So for this, in lesson 4, we're going to get into drawing vectors. Okay, drawing vectors. So because um, it, there are guiding principles, a few guiding principles that we use to draw a vector. Um, uh, so let me give a short explanation here. So we say in order to draw a vector, in order to draw a vector, in order to draw a vector accurately, in order to draw a vector accurately, we must we must represent its magnitude, its magnitude properly, properly, and include a reference and include a reference direction. Include a reference direction in the diagram. In the diagram. So very well. A scale allows us to translate to translate the length of the arrow. And this is important, guys. You should remember this. So a scale allows us to translate the length. Remember what I said previously. What is the length? It's the magnitude of the vector. Okay. So arrow into the magnitude of the vector. The magnitude of the vector. Okay. So that's what the scale does. The magnitude of the vector. So Another thing here, what? Another important thing here to note is that the points of a compass, the points of a compass are often used to show direction. To show direction or alternatively, an arrow. So alternatively, it can be an arrow pointing in the reference direction. In the reference direction. Okay. So now there are guidelines here, okay, that there is a method, okay, that we use. So I wanna outline the step by step. So we have a method here that we use for drawing vectors. Okay. Drawing vectors. So the first thing that we do what? Method, this is the method that we use. So decide upon the first thing that we must do. We must decide upon a scale. Decide upon a scale, yeah, and write it down. And write it down. Because this is the scale that we're going to use throughout the activity that we're given, okay? Decide on a reference direction. That's the second thing we do, okay? Decide on a reference direction. And then the third thing that we must do, we must determine the length, okay? The length of the arrow. So representing the vector. Okay. So we use the scale, using the scale. Okay. using this. You determine the length here using the scale. The scale that we did on the first step is the one that we're going to use to determine the length of the arrow. So, and then the fourth thing, when we now know the length, then we can draw the vector. Draw the vector as an arrow. So make sure that you fill in the arrowhead. So the arrowhead will be the pointer, isn't it? The pointer that shows the direction of them, and then it points in the direction of the reference direction here that we chose in step 2, and then fill in the magnitude of the vector. So we're going to do an example. We're going to do an example here to show you how these things work. Okay, so let's just run down again. So the first thing you do is that what you decide upon a scale. See, you decide upon a scale and write it down. So the scale that you're going to use in that exercise, or whatever exercise that you have. Okay. And then the second, number 2, you have to decide on a reference direction. Okay, because why do we have to divide that? Because anything that goes in the opposite, remember how we defined the vectors, the negative vector. Anything that will go in the opposite direction of the reference direction will become a negative vector. And then determine the length of the arrow, because using the scale, now if we have decided upon a scale, we can then determine the length of the arrow representing the vector using the scale. Draw the vector, because now we have the length. Okay, after we've determined the length, then we can draw the vector as an arrow. Make sure that you fill in the arrowhead to show the direction. This is to show the direction. Fill in the arrowhead so that we can see the direction of that vector. Fill in the magnitude of the vector. Okay, this is it. So now let us do an example here. Let's say example 1. So we're going to use those steps there in order to draw a vector. So draw the following vector quantity. Following vector quantity. So force equals to 8 newtons east. East. So now we can see this is 8 newtons. Okay. So the aim of, so now we go to step 1. What does it say? They say decide on a scale and write it down. So the aim of this scale is that it helps us to fit in the vector on the page. So here we can say 1 centimeter equals to 2 newtons. See? And then step 2, they said decide on the what? The conventional direction. And that's what it says. Decide. So step 2, decide on a reference direction. Set up on a scale and write it down. That's step 1. We wrote it down here. Decide on a reference direction. Okay. So our reference direction here and then our reference direction. So north will point this, so don't say north. Okay. So north will, so in our case here, north will point up the page. North will point up the page. Up the page. And then step 2. Oh no, step 3. So now we can see that because our vector here is what? Is 8 newtons east. So if we are saying, if we say that 1 centimeter is equal to 2 newtons, then, so because this, what then we will have here is, so 8 newtons will be equal to how much? We have to divide, isn't it? We have to say this divided by that. So 8 divided by 2 will be 4. So 8 newtons will be equal to 4 centimeters. Okay. And then step 4, what does it say? So if, so remember that step 4, they say draw the vector as an arrow. Okay. Make sure that you fill in the arrowhead. Okay. Now that we've determined the length, then we can draw the vector, isn't it? So here we are saying that, so the length here has to be 1 centimeter. Okay. So on your page, you see, this has to be 1 centimeter. It has to be 1 centimeter and it's pointing that way. So this is 1, if it's 1 centimeter, it's going to be 2 newtons. And then this one is going to be 4 centimeters. So we come here. It's going to be what we have here. and then it's going to be 4 times longer. So this over here, okay, let me try to make this thing neat. Okay. So we have an arrow here that goes to the east, and the length of this arrow is 1 centimeter. And then now for 8 newtons, it's going to be 4 centimeters. So we must take that, and it should be 4 times bigger. It's 4 centimeters. Yes, that will do. Then they say remember to fill in the arrowhead. So this is 1 centimeter and this is 4 centimeters. So that's how long it should be on your page. See, the page that you're drawing. And then the last step, step 5, they say what? Fill in the magnitude of the vector. So fill in the magnitude of the vector. So then the one that we found here, or the one that's given in the question. So this one is what? Is 8 newtons. And this one is 2 newtons. So step 4 and step 5 will be done simultaneously. So step 4 and step 5 will be done at the same time here, because you just have to fill in from what you have already. So you don't have to do, it's not necessary to show step 5 separately. You see? So yes, you see, this is how it goes step by step. Let's do another example, shall we? So let's move on from example 1. So let's go to example 2 here. Show you another example. Example 2. Example 2. Okay. So for example 2, draw the following vector quantity. Draw the following vector quantity So the velocity equals to 4 meters per second south. So we go to step 1. You must decide upon a scale and write it down, isn't it? Step 1, we must decide upon a scale. Okay. So here we can say, so we have 4 centimeters, so we can say 1 centimeter equals to 2 meters per second, such that, so the aim, so guys, you see, here, the aim of selecting the scale here is such that the vector that we have can fit in on the page. Let's say, for example, they gave us, in another example, let's just say they gave us 40 meters per second. What were we going to do? In this case, how would you select your scale? You would say, for example, 1 centimeter. in this case would be equal to 10 meters per second. You see, such that the whole thing can become 4 centimeters, because you can't say, it's not reasonable if you say that 1 centimeter equals to 1 meter per second, then this thing will become 40 centimeters, you see, and 40 centimeters is bigger than some rulers, and it will be difficult to fit into the page. So the aim of the scale that we're selecting here is such that we can be able to fit the vector onto the page. Okay, so don't select a scale that will make the vector too big, such that it cannot fit into the page, and it will be difficult to fit into the page. See, so your vector must not be bigger than the page that you have. It should be reasonable. So just wanted to make it clear, because sometimes people ask, okay, how do you select the scale? We make it such that it fits onto the page. That's just the aim. And then step 2, we must make what? We must decide on a reference direction. Okay. So again here, our north will point up. Okay. So north is that way. So north will point up. North will point up the page. North will point up page. And then step 3, we must determine the size of the vector. So we must determine the arrow representing the vector, and then using the scale. Okay. So we said 1. So if 1 centimeter here will be equal to 2 meters per second, then what? Then 4 meters per second will be how much? Remember what I said we do the last time? We say this divided by that. It's going to be 4 divided by 2, which gives us 2 centimeters. See? And then step 4. Step 4, then we must, now that we know the length of the vector, then we must draw the vector, isn't it? So we're saying 1 centimeter. So it's south, it's going south, okay? So north is going to point up the page. So meaning south will point down the page. So we start with south. So this is the 1 centimeter that we have, okay? And then the other length that we have is how much? Is 2 centimeters, isn't it? So we have 1 centimeter and 2 centimeters. Those are the two that we have in this activity. So 2 centimeters must be 2 times bigger than what you have here. But then you will have a ruler, isn't it? So your ruler will help you with the measurement here. So this is 2 centimeters, and it must be 2 centimeters on the page, you see. And then the last step is to fill in the magnitude of the vector. So 1 centimeter is, we said 1 centimeter is 2 meters per second. And then 2 centimeters will be 4 meters per second. Four meters per second. Yes. So yes, this is another example, guys. You see, so now these two, they go to the south. Unlike the previous example that was going to the east. Okay. This is south here. In example one, we had what? East. You see. So yes, let's leave it here for lesson 4. Okay. Let's leave it here for lesson 4. And if you have any questions, yeah, you can leave your questions in the comment section. Thank you for tuning in again. I hope that was helpful. And I hope you tune in for lesson 5. Okay. We are still going to continue with vectors and scalars. Leave your questions in the comment section if you don't understand something. Okay. Thank you for tuning in and stay focused. And bye bye for now.